Hello guys, and today we're going to be looking at this question which is discussing, well, we're going to look at what it's discussing. It's about kilowatt hours, and we're going to discuss how to answer this question. So let's dive right in. So the question says the world's biggest offshore wind farm built off the Kent coast started generating electricity in September 2010. So it's telling us that there is a wind farm which is generating electricity from September 2010. Okay, sounds great. Okay, what else do we have here? All right, so then it says the graph shows how wind speed affects the power output from one of the wind turbines. So what we're talking about here are wind turbines that you may have seen off the coasts, or whilst driving down the motorway, you may have seen these wind turbines, and it's effectively talking about this. Yeah, so you've got these blades that are turning on this wind turbine, and it's talking about how wind speed affects it. So there is a formula that if you were to go on to study this at university level, there is a formula that is derived from the wind speed and how that affects power. We're not going to look into that here, but you're more than welcome to look that up in your own time as wider reading. So if we look at this graph, on the left hand side we've got the power output, so the y-axis, and on the x-axis we've got the wind speed, and this wind speed is in meters per second. So those are the key points that we've got here. Then if we look at the question, it says in 1 4-hour period. So there is a 4-hour period. Okay, in that they tell us that the wind turbine transfers 56,000 kilowatt hours. Okay, so 56,000, and kilowatt hours is normally written as such. Okay, it is normally written as such. So kWh. So it says in 4 hours, this is how much kilowatt hours are transferred. Then it says, the question says, use the data in the graph to calculate the average. We're talking about what? The average wind speed, okay, during this 4-hour period. We just need the average for this 4-hour period. So then it says, show clearly how you work out your answer. Okay, fantastic. So before we can dive into this question to work out the average wind speed, we need the average wind speed during average wind speed during the 4-hour period. Okay, that's what we're looking to identify. Okay, so how do you work that out? Well, we've got speed, and the only way we can work out speed using the graph is if we have the associated power with it. So we need to find a corresponding power that will give us the wind speed within that 4-hour period. Well, they tell us what the 4-hour period produces. It produces 5,600 kilowatt hours. So first, the question may arise, what is a kilowatt hours? So kilowatt hours, okay, firstly we must understand what is power and what is energy. So power, often defined as energy over time. So PET is the formula that you may also remember it as. Yeah, so there's a triangle that you may remember it as PET. Okay, it's an easy way to remember it. So this is only for beginners. When you're beginning out, you should use this triangle to help you out. It's a simple acronym as well, PET. But as you get further along, you can just use the normal formula without using the simplified triangle version to help you remember it. So anyways, so this is power, and energy is divided by time. So we know the units for energy are joules, we know the units for this are seconds, and we know the units for this are watts. Okay, so just give this a rub. Okay, so we've got watts equals joules over seconds. All right. Of course, we can also write power. If there was lots of power and we wanted to write kilowatts, we could of course do that as well. Yeah, so we could write kilowatts. Right, what would happen then if you multiplied this factor here, if you rearrange this and you move this time over here, instead of the time being in seconds, so let's say kilowatt seconds, right? Instead of the time being in seconds, if we said kilowatt hours, right? So W large, right? If we said something like this, then what does that represent? Well, clearly that represents power times time. And what is that? That is, from this formula, we know that that is energy. So power times time is energy. So we now know that energy, another way to say energy is kilowatt hours. Okay, so, and you might say, okay, why is it not kilowatt seconds? Well, it could be kilowatt seconds, but it's just the general convention with the amount of power and energy that we're working with. Generally speaking, it makes sense to talk about hours. So if you're talking about national grid, right? So that which transmits electricity across the country, okay? You know, you got these pylons and they're kind of transmitting electricity, and you've got the grid system which is powering during different hours of the day. So if you imagine, say, 12 o'clock in midday, the power required will be different to, say, 3 o'clock in the night. So we normally work with hours rather than seconds or minutes. So hence why it is kilowatt hours. So now we understand that kilowatt hours is in fact energy. So once we've understood that, we can start looking at this. So we're saying in 4 hours, we're producing 5,600 kilowatts. So if we've got the formula P equals PET, right? So P equals E over T, we know that the 5,600 is energy, and we know that the time period is 4. So kilowatt hours divided by hours. So if you do that, you can notice that by simply cancelling the units, you can notice what you will be left with, which will be power. So 5,600 divided by 4 gives you 2,800 divided by 2, which is 1,400. So you get 1,400 watts. Fantastic. So now we've worked out the power is 1,400 watts. So all you now have to do is, remember, they gave you the clue here that you have to use the data in the graph. Okay, so all you now have to do is go to the graph and find where 1,400 is. So quite simply, we're going to read off the graph. So we're going to get 1,400, which I believe is this one here. You go across to this, and then you come down from here, which will give you an answer here. So we just need to work out what the units here are. So if I check this, if that's, it doesn't look, it looks like every 2 blocks is 1. So that's 6, that's 7, that's 8, and that will be 9. And then once we've got that, we'll just check the units. So it's 9 meters per second. So the answer to the question is average wind speed over a 4-hour period was 9 meters per second. Hope that makes sense. If you have any questions, just leave them in the comments below. See you next time.